All right, so what we're looking on here, we want to find the value of x. And as you could see, x is actually here. So the context for this is that we're dealing with two tangents to the circle. So these are the tangents you can see, and they meet at K. So where they meet here, we have an external angle to with an external angle of the circle right there, which came about by the two tangent intersecting at K. Now, what happened when these tangents intersect? We have two intersecting arcs for the circle. For example, let's look at right here. This is the larger arc produced by these tangent at point M and point R. That's the larger arc. And then the smaller arc would be in green right here from M to R, right? So we have two arcs. So whenever we have two tangents that meet outside the circle, this is the theory that the bigger arc minus, which is the measure of the bigger arc, minus the measure of the smaller arc. If we divide this by 2, it's going to give us that external angle in this context at K. So basically what we want to do is we could just easily put on the values. So the bigger arc is MQR, which is 227.17. We're going to subtract the smaller arc, and it has a value of X. Divide this by 2, and it should equal to 47.17. If we're going to solve for X here, what we're going to do now is just to solve this algebraic equation. We're going to multiply both sides by 2. On my left side, this 2 would cancel itself, so I'm left with 227.17 minus X. And this is going to equal to 2 times 47.17. That's going to give me 94.34. To finalize this, I'm going to add X to both sides. So I'll have a positive X. And then I'm going to subtract 94.34 from both sides. So I'm having 132.83 is equal to the value of X. All right, so that's question 1. Let's focus on another question. What we want to do is to find the value of X, and X is the external angle in this case. The principle remains that if we have a secant line, which would have been, the secant line is PD, that's the secant line, and the tangent line, which is FD. If we have a secant line and a tangent line intersecting outside the circle, forming an external angle at D, then that angle is going to be a result of half the difference of the bigger intercepting and the smaller intercepting arcs. For example, the bigger intercepting arc would have been from P to F. The smaller intercepting arc would be from S to F. And you could see that this is where the secant line started at P, and this is where the tangent is at F. So you could see the arc right there. And you could see the smaller one here, which is the second point that the secant line cuts. So we're looking at two arcs each time. So the principle says that if a secant line and a tangent line, right, if they meet outside the circle, that angle that is formed at their intersection is equal to the bigger arc minus the smaller arc over 2. So it's half of that measure. It's going to give us that angle outside, which is x this time. So all we got to do is to substitute. The bigger arc is measured 155 degrees. The smaller arc is measured 63 degrees. Divide that by 2. So basically, 155 minus 63, that's going to give us about 92. And if we divide 92 by 2, then 46 is x. So x has a value of 46 right here. You know, a third problem here, what we have is two secant lines meeting outside the circle to form this angle here, which is 56.05. The question wants us to find the value of x, which is right here. The principle remains that if we have two secant lines that meets outside the circle, this external angle is a result of half the difference of the two intercepting arcs. Now let's highlight those arcs. One, we have an arc PF, this here, and we have another arc, which is the smaller version, SA. So those are our two arcs that we have right there. So now the principle says that the theory is that it's going to be the bigger arc minus the smaller arc. If you divide this by 2, it's going to give you the angle at D. So the difference between the two intercepting arcs, half of that is going to equal to the angle, which is the external angle formed where the secant lines met. So let us take a look. So X is the bigger arc, which is PF, minus the smaller version, which is 71.4. Divide this by 2. The result is 56.05. So let us solve this. We're going to multiply. We're going to multiply both sides by 2. So we have our 2 cancel there. We have x minus 71.4 is equal to, times 2 is going to give us 112.1. And then we're going to be adding 71.4. So x is equal to 183.5. So that is the value of this arc right here.